CrowdStrike bought SGNL for just-in-time agent permissions. Cisco bought Asterix for agent credential visibility. Palo Alto acquired CyberArk's privileged access management capabilities. They are not buying anticipation, they are buying response. The question that none of those acquisitions answers is whether the human session that authorized the agents was cryptographically sound to begin with. If an adversary is positioned between your user and your agent orchestration platform, the agents will execute instructions from that adversary with the full scope of your user's delegation. FIDO2 closes that gap, not for the agents, for the human at the origin of the chain. EA Thursday on the Hamberger report. Link in bio.
Let's get into it.
In 2014, the first phishing-resistant authentication standard shipped. 12 years later, the attack it was designed to close is appearing at the human-to-agent boundary. This is the Hamberger report. I'm Andreas Hamberger, Enterprise Architect, Wellington. In January 2026, CrowdStrike acquired SGNL, a just-in-time agent permissions platform. In February, Palo Alto Networks closed on CyberArk's privileged access management capabilities. In May, Cisco acquired Asterix Security. 3 acquisitions, 3 of the 5 largest enterprise security vendors. 4 months. When capital moves that fast, the incident data that drove it already exists. 88% of organizations reported at least one AI agent security incident last year. 22% of those incidents involved an identity-bearing agent, an agent that held credentials and that became part of an attack chain precisely because that identity was in play. The question this episode addresses is not whether your agents can authenticate, it is whether the human who authorized them was actually there. FIDO2 is 2 specifications operating together. WebAuthn governs the browser-to-server authentication exchange. CTAP2 governs the browser-to-hardware device exchange. Together they define phishing-resistant authentication, authentication that cannot be intercepted and replayed by an adversary positioned between the user and the legitimate service. The cryptographic mechanism is verifier impersonation resistance. The FIDO2 credential is mathematically bound to the relying party domain, the specific domain name of the legitimate service. The browser includes that domain in the authentication ceremony. The private key held in hardware signs a challenge that includes the domain. An adversary running a convincing phishing site cannot intercept the response and replay it against the real service. The mess will not validate. Passkeys are the device-bound implementation of FIDO2. The private key never leaves the device. The credential cannot be extracted, phished, or credential stuffed. Synced passkeys, including those managed by platform sync services, do not qualify for Authentication Assurance Level 3. Device-bound passkeys and hardware security keys qualify for Authentication Assurance Level 3. For privileged access in New Zealand Information Security Manual-governed environments, the hardware-anchored credential is the standard. This is Chapter 18 of Zero Trust Architecture for the Agentic Enterprise. Chapter 17 provided workload identity with IFEA and SPIRE, how agents prove to other systems who they are. This chapter addresses the orthogonal problem. Every agent action chain has an origin. Somewhere in that chain, a human authorized something. The human may not have authorized every subsequent action. In a multi-agent pipeline, the initiating human may be several steps upstream from the agent that took the consequential action. But the authorization chain began with a human interaction. If that originating interaction is not cryptographically sound, the entire downstream chain is built on a foundation an attacker can reach. An adversary who compromises a human user's authentication to an agent orchestration system does not need to attack the agents directly. They can issue instructions that appear to come from the authenticated human with the full permission scope of that human's authorized delegation. The agents properly authenticated to each other via SPIF will execute those instructions because the orchestration system believes the human is in the session. Lethal by Design is running every Friday right now on this channel, working through exactly this class of accountability gap in the highest stakes domain. If AI governance is in your scope, the channel publishes daily. FIDO2 was designed for a specific trust model. a human being present at a physical device, authenticating through a browser. 3 constraints shape how agent deployments strain that model. First, continuous operation without human presence. A FIDO2 session is initiated by a human gesture. The session, even if FIDO2 initiated, eventually requires re-establishment or long-lived token derivatives that are not themselves hardware anchored. The mitigation is not to extend the session indefinitely, but to require re-authentication for high-consequence delegations. An agent authorized to read and summarize documents might operate on a long-lived token. An agent authorized to initiate payments, send external communications, or modify access controls should require a fresh FIDO2 ceremony for each action class. Second, non-human principles in the orchestration chain. When an agent delegates to a sub-agent, the delegating principle is not human. FIDO2 does not apply to agent-to-agent authentication, that is SPIFI's domain. The boundary question is how far downstream the human's FIDO2 anchor remains traceable. Third, the absence of a finalized FIDO2 specification for agent principles. The FIDO Alliance working group on this topic is in progress, not resolved. Architects deploying agent authentication now are building ahead of the standard. The principle FIDO2 applies at the human-to-agent boundary is not new to the defense and intelligence community. The United States Department of Defense's Personal Identity Verification and Common Access Card standards embeds the same requirement: cryptographic authentication per transaction, not implicit trust from a prior authenticated session. Personal identity verification credentials, governed by NIST SB 873 and implemented across United States federal agencies and allied access contexts, are hardware-anchored, phishing-resistant, and bound to a specific physical card that cannot be replicated. The Common Access Card is the Department of Defense-specific implementation. 2 million active cards carrying credentials that gate access to classified networks, weapon systems management, and logistics chains. Both standards treat authentication as a per-access event, not a per-session assumption. New Zealand public sector architects deploying agent systems in health, social housing, or justice contexts are not dealing with classified networks, but the accountability requirements are analogous. The personal identity verification and common access card standards prove that hardware-anchored per-transaction identity is operationally sustainable at scale. FIDO2 delivers the same architecture for the environments where those standards do not reach, including the agent orchestration platforms being deployed across the New Zealand public sector today. What the defense community proved is that authentication cannot be a session assumption. That lesson translates directly. The trusted execution environment addresses the agent-side credential binding problem, the same hardware anchor property FIDO2 provides for humans, now applied to software agents running in dedicated hardware-isolated compute environments. If FIDO2's security property is that the private key is bound to a device that cannot be remotely compromised without physical access, the analogous property for an agent is that the agent's identity credential is bound to a trusted execution environment that cannot be compromised by an attacker operating outside its boundary. ARM Trust Zone, Intel SGX, and AMD SCV each provide hardware-enforced isolation for computation. Code and data within the trusted execution environment cannot be accessed or modified by the host operating system, hypervisor, or other processes running on the same machine. Extending FIDO2 attestation to agent issuance events means before an agent is issued a credential, the issuance event should include an attestation that the agent is running within a trusted execution environment whose integrity has been verified. The FIDO Alliance Working Group has not finalized the standard. As of June 2026, the practical interim is a layered architecture. FIDO2 at the human-to-agent boundary, SWIFT for agent-to-agent authentication, and trusted execution environment anchored credential issuance for agents in the highest sensitivity contexts. The 3 layers address different threat vectors and are not redundant. New Zealand's Privacy Act 2020, amended by the Privacy Amendment Act 2025, and effective from the 1st of May 2026, introduced an explanation obligation for automated decisions. The connection to agent authentication is direct and legally consequential. The explanation obligation can only be discharged if the decision maker can be identified. If the agent that made the decision cannot be cryptographically attributed to the human principal who authorized its operation, the chain of accountability is broken at the identity layer. This is not a compliance observation for future consideration. The amendment is operative now. The FIDO2 session identifier, propagated through the agent workflow as a correlation identifier, becomes the linchpin of that accountability chain. The human who initiated the session is identified by their FIDO2 credential. The agents that operated within that session are identified by their SVIDs. The delegation chain from human to agent to decision is traceable, immutable, and tied to a cryptographic authentication event that cannot be spoofed. NCISM version 3.9, the 5-Country Council Guidance, and the Privacy Amendment Act 2025 converge on the same architectural requirement. FIDO2 at the human boundary is not one option among several. If one of your AI agents made a consequential automated decision last week, could you trace it to a verified human who was genuinely there?
That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Like and subscribe.